Welcome to Vision Plus and welcome back to this S.4 Mathematics. Today we want to see how we can find the gradient of a curve at a given point. So straight away to example 1. Example 1 says, part A, find the gradient of the curve y equals to 3x squared plus 2x plus 1 at the point 2 and 3. So for part A, we are given a curve y equals to 3x squared plus 2x plus 1 at the gradient of this curve at the point 2 and 3. Now, for us to find the gradient of the curve at any given point, say 2 and 3, we need to first get the gradient function of the curve. What is the gradient function of the curve? The gradient function of the curve is the derivative of the curve. That means we need to differentiate the given function of the curve. So let us differentiate this function. In this case, 1, you can use the method of powers and coefficients, or you can differentiate from first principles. But for first principles, it takes a lot of steps and a lot of time. So we shall not use it because here the choice is ours. So let us take the step that gives us the answer quickly. Now we are going to differentiate this function using the method of powers and coefficients. So we shall say dy dx, and you know that equals to, when we differentiate 3x squared, we shall get 3x. We shall get 6x plus, when we differentiate 2x, we shall get 2. When we differentiate 1, we shall get 0 because 1 is a constant. So this is what we are calling the gradient function. Now, what is the importance of the gradient function? The importance of the gradient function is that it defines for us what the gradient of the curve would be at any given point. So this gradient function applies to anywhere on the curve. The curve is something in this manner, or can be in this manner, or can be in this manner, in any way. So the gradient function defines for us generally what the gradient would be at any point on that curve. So after getting the gradient function, now what is the gradient of the tangent? Not the tangent. What is the gradient of the curve at this point? So you just come and say, therefore, dy dx at the given points 2 and 3 would be, then from here you substitute. Remember, the first coordinate is always for x and the second is always for y. So we substitute for these points in the gradient function like that you can obtain the gradient at that point. So here we shall have 6 into x is 2 plus 2. Just substitute for x here. This here gives us 12 plus 2, 14. So 14 is the gradient of this curve at the point 2 and 3. Therefore, the gradient is 14. And simply, that is the solution for part A. Going to part B. Part B is the same as part A, just that we have a different curve and we have a different point where we need the gradient. So part B says, find the gradient of the curve y equals to x cubed plus 2x squared plus 3x. At what point? At point 1 and 4. So they need the gradient of that curve at a point 1 and 4. So what do? We need to get the gradient function such that It defines for us what the gradient of the curve would be at any point on the curve. So we differentiate. We say dy dx. So we differentiate the curve. That gives us that dy dx equals to, when we differentiate x cubed, we get 3x squared plus, when we differentiate 2x squared, it gives us 4x plus, when we differentiate 3x, it gives us 3. So this is the gradient function of the curve, and this is the function that defines for us the gradient of the curve at any given point. But now we have this point, so we say at point 1 and 4, now the gradient dy dx at that point 1 and 4 would be, this is x, this is y. After putting these coordinate points down here, then this is no longer a gradient function, but now it is a gradient because we have the points. So we substitute in this equation, substitute for x as 1 in the gradient function. So that we have 3 into x is 1, that is squared, plus 4 times x, which is 1, plus 3. And then we simplify. This gives us, you can even use a calculator. 3 times 1 squared plus 4, 3 plus 4 plus 3. I'm getting 10. So 10 is the gradient of this curve at the point 1 and 4. Therefore, gradient equals to 10. And simply, this is the answer for part B, and that is how we find the gradients of curves at given points.